Okay, so this is the video explanation uh, for recitation number 2, and specifically for problem 1C. So this is the problem about the black-skinned and the pink-skinned pigs, where you have to calculate the probability of 3 piglets, and those piglets would be 2 pink piglets and a black piglet. And obviously you can have 3 combinations of that: pink, pink, black, black, pink, and then black, pink, pink. So to do this, you've got to, unfortunately, folks, use a binomial expansion. So we'll talk through that and then see where we go from there. Okay, so use binomial expansion when there are 2 outcomes and you've got a number of sequential independent events happening. And so here we've got two events, and your textbook's going to use A and B or P and Q or something like that. I'm going to use P and B here, just because I think it makes it easier with the pink and the black skinned phenotypes. So is what we're going to do is start with the binomial equation, which is P plus B, and there are 3 independent events. That's P plus B raised to the 3rd power. Now your book is going to show you is going to say A plus B to the 3rd power. If you've done any population genetics, you're going to actually you'll start looking at P and Q, and it doesn't matter. It doesn't matter. These are all they just represent an outcome. So here I'm using P for pink and B for black. So we'll use this convention here just because it's easiest. So if we expand that that polynomial, basically P plus B to the 3rd power, and don't forget that equals that's going to equal 1 because that's the sum of all of the possible outcome combinations. And if we expand the binomial, then we're going to end up with P to the 3rd power plus 3 P squared B plus 3PB squared plus B to the 3rd power. So if you don't know how to do a binomial expansion, then you can go and Google some stuff, and it's pretty obvious. There are patterns and stuff you can start to see. But your exam will be open textbook, so if you need to look that up, you can look that up. That's just a quick look up. So it's what we need to work to figure out exactly what these P to the 3rd and 3P squared B's mean. So let's start with P to the 3rd power. Now, what that means is that you got 3 pink-skinned piglets. That's all that means. And then obviously over here at this end, we've got 3 black-skinned piglets. There's only one way that you can get those events. And then let's think about the probability of getting 3 pink-skinned piglets. And if you go back to the first part of the question, the probability of getting 1 pink-skinned piglet is 1/4, because that's determined in an autosomal recessive manner. So what we would have there is simply 1/4 times 1/4 times 1/4. I'm not going to do the math there. You can figure it out. Then if we come over to the 3 black piglets, the probability of that would be simply the product of 3/4, 0.75, times 3/4 times 3/4, and again you can figure out the math. I'm not going to do that for you. Is what we want to know: what is the probability associated with having 2 pink and 1 black piggy? So that would be this this event here. And so if we think about what that means, it means we could have pink, pink, black, and this is coming from up here. We could have pink, black. Pink, black. No, let's kind of back up there. I've messed it up a little bit. Let me find the eraser here real quick. There we go. So if we're looking for 2 pink piggies, we could have pink, pink, black. We could have pink, black, pink, and then we could have black, pink, pink. And so we're basically asking, what is the probability of this event happening? And so all we do is we use the formula 3p squared b. So we would do 3 and we would do then the probability of a pink piglet, which would be 1/4, and then we would square that, and we would multiply that by the probability of a black piglet, which would be 3/4. And you can do all the math and work that out, and it's going to come out to 0.14 or 14%. So you should be able to calculate what is the probability of getting 3 piglets where 1 is pink and 2 are black. And that's how you solve problem 1C using a binomial expansion.